Hey guys, we're back, this time with 3D printed calipers. These are the latest in our functional tool series. You can download them yourself. The files are free and they're up on all the download sites. Check the bio for links. In this video, we're going to go through design and some of the considerations and how this thing works. We'll show you how to set up the print bed and print your own, and then we'll go through assembly and do a little bit of testing at the end to show you how these things work.
Let's take a look at the design of the calipers. Now these are tools to measure stuff. So we want to bring these two faces, touch the outsides of some part, and whatever the distance is between these faces is the number that we read here and on the dial. So the numbers on the dial represent 1 millimeter per number. The dashes are half millimeters, and the fixed jaw is marked off in tens. So for every revolution of the dial, it'll expose another line, and it's 10 millimeters around. We needed to slide on the outside of this rectangular part, so the housing had to come apart to go around it. The gears in the middle go right through it. And then we've got this friction wheel that you can push in against these chamfered surfaces and roll to move the carriage back and forth. The last function of this is you can also measure the depth of something if you touch this face and this face. So the distance between these two faces is always the same as the distance between this face and this one. So there's two different ways you can measure with this, and those lengths will always be equal. So let's take a look at what's inside of here. If we turn this guy off, we can see that we have one gear engaged with the rack, and this gear has a circumference of 30 millimeters. For every time this rotates one revolution, you've moved 30 millimeters left and right. What we need is a 10 millimeter revolution, so we've gone with the 3-to-1 reduction, so that every time that this gear spins one revolution, this one will spin 3. And that means that the 30 millimeters that this gear rotates will result in 3 turns of the dial. So that was how we used the gear ratios and the distances to get this thing to be an accurate measurement to a nice round number. The pins and holes for the gears had to be rearranged so that we could print with no support. For instance, this guy has a pin on one side, but the other side is a hole, and there's a pin coming from the housing on the other side. So we just had to use some clever splitting of the material, and we used friction posts again, so this thing does go together like Legos, and just separate it into 3 pieces so that we could print everything with no support. And even in the bottom of these, we've added peaks so that we could print overhangs and then just keep on going with a flat surface, because stringing across open spaces is really difficult to control. So I wanted higher percentage things for us all to be able to print and everyone to be successful. So we've got one double gear in there, and then this small gear. The small gear's post reaches through. This pointer is pressed onto it, so when the gear spins, the pointer spins. And that's pretty much it. We've got these types of female sockets and corresponding male posts on the opposite side. And here are the male posts on the opposite side. These male features fit into these female features, and they interfere, and friction holds them in place. They get you good face-to-face contact, and they're pretty difficult to get underneath to pull them back apart, but you can disassemble the thing and then reassemble it as many times as you want. There's going to be a limit to that because these are 3D printed parts, but I've had them apart and back together quite a few times, and they still repeat. They work great. So let's take a look next at how to set up the build plate and print one of these yourself. We can start with the fixed blade. We're just going to face the text up, and that's going to print fine. This is the rear wall of the housing. We want the holes down and the posts up. All of the posts are up on everything. So this is the base. We've got half the post for the friction wheel. This is a post for the gears and the posts that actually hold the thing together, the kind of Lego features. So we want this part in this orientation. The friction wheel itself is just on its side. The housing is got the numbers side down so that we can print these posts face up and we can print these sockets. The gears are large gear size down. The small gear just post up, and the pointer looks like this. So set them up like this. This doesn't have any great need for strength. Low layer height might be a good idea on this one. The more precision you have, the better. So no really crazy print settings on this one, just PLA should be fine. So now that we've got the print bed set up and we can get these parts made, let's take a look at assembly.
Here are all the parts we need to print to make our own calipers. This is the orientation they should have been printed in, so that everything printed with no support and your parts are just ready to go. So we're going to start with gears. So this is the dial. It's face down. We're going to put the big gear on the post, and we're going to put the little gear facing down, get it in that hole, and mesh the gear teeth. This should spin freely right now, but these are only supported on one side so far, so they're not perfect yet. We're going to take this back post, put the connecting features in. These kind of connect like Legos. Then the jaw mixed with the rest of the housing. So that's the other wall for sliding. Now, this guy numbers down over this, so it goes between the two pieces that I have printed in blue, and it's going to mesh with this gear. The other little gear should be down underneath it and should never touch these teeth. Friction wheel goes on this post, and you have to work it underneath here, like so. And then, last piece, we put this bottom housing on. We've got to get that shaft from the gear in the hole, line it up, push it down good. Okay, now, the only thing we have left is a pointer. So, I want to close the jaws, put the pointer on, pointing right at 0, and just push it down. You can twist it a little to adjust it, but it should point right at the 0. You can push it from this side once it's aligned, and that'll make it sit flush with the top of the pin. And that's it. Now, when we slide it, we can measure whatever the distance between here is and the distance between these two faces if you want to do a depth like this. So that gives you the distance between this surface and this surface. So that's the other measurement type we can do with this guy. Time to do some testing. So I've got these Mitutoyo calipers you can buy online. We're going to measure with both and see how accurate we are. So we're looking at 39.97 here, and ours measure 40. This one's 74.85 versus 74.5. We've got 22.48, and ours measures 22. 8.03 versus 77.5. And the last one, we've got 12.5 even on both. So not bad. We're not quite as accurate as the store-bought one, but we're real close. You know, it's certainly a functional thing we can measure with, and if you don't have calipers, this is infinitely better than none. Let us know in the comments if you have any ideas for upgrades or future projects, and be sure to subscribe for more content.